Hello everyone, welcome back to a lecture series on thermal aspects in metal cutting. So in my last video I was discussing about the method of measuring the temperature during a metal cutting operation, and we have discussed the different methods related for the measurement of a temperature. In today's lecture I am going to cover the topic called as a tool life. So before defining the tool life, let's have how we are going to define the tool life. See, whatever the device we are using in our daily life, whatever it may be, it has got its own particular period of usage. After that it will become useless, or you cannot use that device more efficiently after some period or some time, or by using that device for a particular duration. For example, you are using your mobile phone, so it has got its fixed life. So after a certain period of usage of a mobile phone, it may not work efficiently or it may not function efficiently. So after that its ability to function efficiently will get decreased. So this period or this duration, we are calling it as a life period or life of that particular device. One more example you can take in your daily life, in your household works, in kitchen, especially in kitchen we are using knife that is used as a cutting tool. So again the knife we are using, it will cut all the types of vegetables which we are using in our kitchen. So the knife will cut that vegetables efficiently for a particular or for a fixed period or for a fixed duration. After that it will lose its sharpness, it will become dull, and it may not work more efficiently as it was working earlier. So what is this indicates? What this period or life indicates? So this indicates the life of that particular tool or device. Similarly, in a metal cutting operation, we are using the cutting tool to cut or to remove the material from the workpiece. So whenever we use a new tool for cutting purpose, it will remove efficiently the required amount of a material from the workpiece more efficiently. But due to its prolonged use or for a long duration, when we make use of that same tool for cutting purpose again and again, it may lose its sharpness, it may lose its ability to cut the material. So the duration for which we are using the tool to cut the material or to remove the material in an efficient way, so that duration or that time we are calling it as a tool life. There are various ways by which we can define the tool life. It is the period during which a tool cuts satisfactorily, or the total time accumulated before tool failure occurs. Before tool gets failure, so whatever the time is accumulated or for whatever the period the tool has worked, so that period or time we are calling it as a tool life. So now how we are going to define the tool life? So in the year 1907, F.W. Taylor, he has proposed one equation for defining the tool life, and that equation we are calling it as a Taylor's tool life equation, and it is given by Vc T raised to n is equals to C. What is Vc stands for? Vc stands for the cutting speed, and it is measured in terms of mm per minute. What is T stands for? T stands for tool life. It is measured in terms of minutes. N is a tool life index, and it depends upon the type of tool material or workpiece material which you are cutting. C is the machining constant. So here, by using this Taylor's tool life equation, we can easily determine what is the life of the particular tool. Now this equation has further modified by adding or by considering the feed and depth of cut. So the modified Taylor's equation will looks like somewhat like this, that is indicated in equation number 2, that is Vc T raised to n d raised to x f raised to y is equals to C. or you can rewrite this equation in this form to determine the tool life T, where D stands for depth of cut in mm, F stands for feed in mm per revolution or mm per stroke, you can say. X and Y are the exponents. These exponents you can determine by conducting some experiments on different materials by using different tools, and you can get a machining book. From that machining book you can collect the data for X and Y for a particular operation. Now the value of n, for example, the value of n exponent for tool life which we are using, it may vary from 0.1 to 0.2 if you are using high speed steel cutting tool, if your tool is made up of HSS. The value of n will vary from 0.2 to 0.4 if you are using carbide tip tool for your particular machining operation, and value of n will vary from 0.4 to 0.6 if you are using ceramic type of a tool. So this is the Taylor's tool life, modified Taylor's tool life equation, by the help of which we can easily determine the life of the tool. Now let us discuss what are the factors which are going to affect the tool life. First factor is the cutting speed. So when you increase the cutting speed, definitely you are increasing the load on the tool. So due to which the friction will be more, the heat generation will be more, the temperature built up in the tool and in the chip part will be more. And when the temperature increases, so some of the small cutting particles or removed particles will get stick to the chip, and this chip will slide on the tool face, and due to this sliding action of the chip on the tool face, friction will occur, and due to this friction, rubbing action or scratching action will occur on the tool, due to which the life of the tool will get reduced. Depth of cut and feed, this will also affect the cutting tool life, and increasing the depth of cut or feed for a particular cutting operation may affect the tool life. Workpiece hardness, if you are using the workpiece material to be cut very hard, if it is very brittle and hard, then it will become very difficult for the tool to cut such type of a material. So it needs more power, more cutting forces. Increasing the cutting forces once again increases the friction, and again increase in the friction will increase the temperature, and again increase in the temperature may create the softness for the tool, and when the tool becomes soft, so it may lose its sharpness at the cutting edge. So therefore the workpiece hardness will also affect the tool life. Tool material, so what type of a tool material we are using for a particular operation to cut a particular or a specific workpiece material, so that also plays a very important role in controlling the tool life. Type of coolant which we are using, so which type of a cutting operation you are performing, and for that particular cutting operation or machining operation which type of a coolant is suitable, so that also you have to see. Tool geometry, so whether you have used the proper tool geometry, that is a rake face angle, whether you have fixed the particular rake angle or not, that also you have to see. That is the tool geometry is going to affect. Tool wear means whether it is a crater wear or whether it is a flank wear, again it is going to affect the tool life. So this is about the short discussion on the tool life, how we can define the tool life and what are the factors which will affect the tool life. So thank you for watching this video. Keep watching this video. So I am going to discuss further more topics on the thermal aspects in my next video. Thank you once again.